In this video, we're going to be working out a rotational problem where a bullet is coming in and striking a beam and then causing it to rotate, and we're going to find that omega value as soon as the bullet and beam rotate together. So first of all, we have all of the initial angular momentum, which is going to be equal to all of the final angular momentum based on the conservation of momentum. So what we're going to do is take a look at all the initial values, and for the bullet, we'll go ahead and write that as I for the bullet, and then it has a certain omega I value for the bullet. And then it doesn't have anything that's going to be added or subtracted to it because the plank is at rest. So that's all of our initial angular momentum. Now afterwards, when the bullet implants itself into the beam, we now have the I of the bullet plus the I of the beam. And we'll just put BE so we know that it's the beam. And we're going to combine those two moment of inertias and multiply that by the omega final, which is going to be our final answer right here for the omega. So let's go ahead and do some substitutions. One substitution I'm going to do in a moment here has to deal with using the linear velocity as r times omega, and we're going to just rearrange that a bit and say omega equals v over r, and we'll make that substitution in a moment here. So for the rotation of inertia of the bullet, because it's implanting itself at the very edge of the radius here, that's going to get the full r squared. And then we're going to sub out the omega for v over r. And then on the other side, we have the I of the bullet, which we said is the mr squared plus the I of the beam. And the beam is going to be 1/3 r squared because it's a rod rotating about its end right there. And then we're going to be finding the omega f. So what we can do is we can cancel a few things out, plug in some of our number values, and then we'll see what we get for our omega f value. All right, so I plugged in all my number values. I had one of the r's cancel out, so I basically had mrv of the bullet as my numerator, and I made sure I took my 15 grams and divided it by 1,000, making it 0.015 kilograms. And then after I did that, I took my r value of 2 because the beam is going to be 2 and its pivot point is right there. So the whole length of the beam itself is the radius. That's where the 2 came from. The 350 was the initial velocity of the bullet written in the beginning of the problem. And then on the bottom here, we have some I value for the bullet. So the 0.015 times r squared. And then for the beam, 1/3 r squared for the moment of inertia of the beam. And then from there, basically just found the product of a bunch of things, added these things in the denominator, divided it out, and I got 1.95 radians per second. That is my final answer for the omega value after the bullet implants itself into that wooden plank. So I hope that was helpful to you in setting up a rotational angular momentum problem. Thank you for watching and listening.